Hello everyone, hopefully you're doing well. In this particular video, we're going to solve a problems that, it's a related rate problems. Remember to solve related rate problems, you need to make a simple sketch and set up an equations relating all the relevant quantities and differentiate implicitly both sides with respect to time and substitution values for all known quantities and derivatives. And of course, we're going to solve for the remaining rate. So related rates, we need to derive with respect to time. But when you look at this problem here, it says a point moves along the curve y equal square root of x in such a way that the y component of the position of the point is increasing at a rate of 3 units per second. So this 3 units per second you see right here, that's represent, a dy dt, which is 3. So because it's increasing at a rate of 3, because they said is the y component. So at what rate is the x component changing? So with respect to time also, so let's say that they gave us a dy dt. Let me change the color. I think the color would make it much easier for you to see. I'm gonna choose red. Okay. Now, what happened, we're going to take, we know dy dt equal 3. Now, what they ask us to do is really to find dx dt. So that's the one we're gonna find. Once we find dx dt, we're going to substitute for these values of x in a, b, and c. Now, first of all, how to find dx dt? We know y equals square root of x, or you can simply write y equal x power 1/2. Now, if you derive with respect to x, you're going to have dy dx equal, bring the 1/2 in the front, x power 1/2 minus 1. Remember, you do 1/2 minus 1. So your dy dx would simply be 1/2 x power -1. But remember, you should never leave your exponent negative. You end up having dy dx equal 1/2 x power 1/2. You know x power 1/2 is square root. So dy dx equal 1/2 square root of x. Now that you know it's square root of 1/square root of x, remember when you have dy dx equal 1/2 square roots of x, but we know we don't know dy dx, we know dy dt, and we're looking for dx dt. So what we're going to do at this point is to multiply both sides. We're going to multiply both sides of the equation by dx dt. dx dt. So what's next? Once you multiply both sides by that, you can really simplify dx. We have dy dt now in this side equal 1/2 square roots of x times dx dt. Next step is really to multiply both sides of the equation by 2 over x, 2 square root of x. If we multiply both sides by 2 square root of x, so we end up having in this side 2 square root of x dy dx dt. And then in the other side, if you multiply by 2 square root of x, 2 square root of x is done. So we have dx dt. So if you want to rewrite it in the other way around, you can rewrite dx dt equal 2 square roots of x dy dt. So now this is what you need. Once you have that related rate, you can answer all the three questions. Remember, the first questions they ask you, we need to substitute for x equal 1/3, but remember x equal 1/3, but dy dt, we know what it is. It's 3. So at this point, we're going to have dx dt equal 2 square roots of 1/3 times 3. That gives us 6 square roots of 1/3. You know how to rationalize. You're going to have 6 over square roots of 3. When you multiply by 3, divide by 3, you know the answer for this one would be equal to 2 square roots of 3. So just simplify. Remember, you simply need to do some algebra. Once you do some algebra, and that would be the correct answer for that one. We can answer the second question, B, where we said x equal 1 and dy dt still the same, 3. We said dx dt would be 2 square roots of 1 times 3. That gives us 6. No, it's really a beautiful 6. Let me write a beautiful 6 for you right here. Okay. Last questions is to find that rate when x equals 4 and the dy dt still the same, 3. So what you do, dx dt would be equal to 2 square roots of 4 times 3. That gives us 2 times 2 times 3, it's 12. So when answer the 3 questions they ask us to do. Related rate is really with respect to type, but what they give us in these examples, they give us the y component in with respect to t, but when we derive y equals square root of x, it's a dy dx. That's why we multiply both sides by dx dt in order to obtain the rate of the x component, which is dx dt, and also obtain the y component that we know, so we could cancel the dx on the left hand side. So hopefully you use this example to do more related with problems for calculus 1. You let me know if you have any more questions. Don't forget to subscribe for more video. Take care.